In this section, we will look at using Windows Server 2008 as a router. In most cases, you will use a hardware router on a commercial network, but for the exam, you need to know how to configure a router. If you ever use your server for remote access, it pays to understand how routing works inside Windows Server 2008. Routing is the process of selecting a path through a network for your data to travel. Consider this. A computer is connected to a switch. It can communicate directly with any other device connected to this switch. For example, this printer, assuming the device has an IP address in that subnet. In this case, any device starting with an IP address 10.0.1. If the computer wants to communicate with another computer on a different subnet, it cannot do it directly. In order to communicate with the other computer, it must go through a router. The computer will have its default gateway set to the router's IP address, which is 10.0.1.1 in this example. The router shown in this example has an IP address in each subnet. Using this IP address, it can communicate directly with any computer or device on that network and act as a bridge between networks. In this case, the IP address is directly connected to the router, but in a lot of cases, this will not be the case. Imagine the computer wants to communicate with a server on the 10.0.4 network. The router is not connected to this network, but by looking at its routing table, you would conclude that the route to this network is through the second router. The router is directly connected to this network and thus will send any data for that server directly to that network. If a computer was directly connected to this router as well as on a different subnet, any data from this network would also be transferred to this router. If the second router received any traffic for the 10.0.1 and 10.0.2 networks, it would know from its routing table to send the data to the first router. If a computer wants to send data to the Internet, the second router would need to send that traffic directly to its Internet connection. As you can see, the first router is connected to 3 networks, while the second router is connected to 4 networks. Routing is the process of deciding a path for your data to travel. The Internet routing tables can have hundreds or even thousands of routes in them, depending on how complex the network is at that location. To better understand routing, you should take some time to understand the MAC, or Media Access Control address. The MAC address is a 48-bit unique address that is present on every network adapter. The address is guaranteed to be unique. If the following computer wants to communicate with another computer on the same subnet, the computer needs the other computer's MAC address to communicate with it directly. In order to get the other computer's MAC address, an IP version 4 based computer uses ARP, or Address Resolution Protocol. ARP finds the MAC address of another computer or device on the local network. It does this by sending a broadcast to all computers on the network asking for the MAC address for the following IP address. The computer with the IP address will respond, "This is my MAC address." Using the MAC addresses, the computers can communicate with each other directly. In a large network, you may have multiple switches and routers on the same network. The switches will keep a record of which MAC addresses are on which port. Using these MAC addresses, the switches make routing decisions on the local network regarding where to send packets. This is an example of Layer 2 routing. If the computer needs to communicate with a computer that is not on the local network, the computer will send the data to the local router. ARP will again be used to obtain the MAC address of the router. The computer will communicate with the router using direct communication. The router will then pass on the traffic using the same process to other routers or directly to the target computer or device. To start using Windows Server 2008 as a router, you need to install it. Let's have a look at how to install the router. To install the routing service, run Server Manager from Administrative Tools under the Start menu or from the Quick Launch bar if it is available. Select Roles from the left-hand side and then select Add Roles from the right-hand side. In the wizard, select the role Network Policy and Access Services from the list. There are a few different components inside Network Policy and Access Services. The one required for routing is Routing. This will in turn select Routing and Remote Access Services and Remote Access Service. Routing is a feature of Remote Access Services. However, if you only want to use your server as a router and not for remote access, you can simply not enable any other features. There is nothing else that needs to be configured for routing. The install is quite simple. Once the install has finished, which will take a few minutes, you need to configure routing and remote access. To do this, run the Routing and Remote Access Snap-in from Administrative Tools under the Start menu. From the Admin tool, right-click on your server and select the option Configure and Enable Routing and Remote Access. Even though routing is installed, it is disabled by default until you configure it. On the configuration screen, you can see there are a lot of different ways routing and remote access can be configured. On this server, I only want to use the router functions. To do this, select Custom Configuration. This will allow you to select the options you wish to use. In this case, I want LAN routing. Once I press the Finish button, I will get the option to start the remote access service. Once the service is started, your Windows Server 2008 router is ready to go. Windows Server 2008 allows you to create static routes. These are manually created routes that are added to the routing table. These static routes override dynamic routes. Static routes can also be created on client computers like Windows Vista and Windows 7. Consider this example. The client computer wants to access the test network. If you add a route to the main site router, you can route traffic for that subnet to the test network. However, this does mean that all computers in that network will first go to the site router and then to the test router. This means to get the test network, the computer must pass through two routers, or what is referred to as hops. Also, the traffic must pass back through the same interface on the site router that it came in on. Most routers will allow you to do this, but you may find if your router is also a firewall, it may get blocked. To prevent this, you add a static route to only the client computer, allowing the client computer to connect to the test network directly. However, regular users, without the additional static route, will not be able to access the test network. To add a route, use the following command. Note, you can also add routes using the Admin tool if you are on Windows Server 2008, but it is useful to know the command line tool as well. To add a route, open the command prompt and enter the command route. If you put in the -P option, the route will be persistent. In other words, the route will still be there when you reboot the computer. The add parameter tells route you want to add a new route. Next, put in the destination network, followed by the word mask, and then the network mask, and finally, the gateway you want the traffic to exit by. This is usually the IP address of the interface you want it to leave by. However, you could put in another device or router on the network. Once added, you can view the route table by entering in route print. I have added the -4 switch so that I will only see IP version 4 routes. As you can see, the persistent route is at the bottom of the screen. On a well-designed network, you should only ever need to add routes to your routers, but it is good to know how to add routes to your local computer if your traffic does not go where you want it to. Often, VPN clients will change routes on your local computer. Remember this if you start having problems with routing later on. This is called split tunneling, in which certain traffic goes to the VPN tunnel and other traffic goes to the local network. When troubleshooting network problems, it is often useful to look at the local routing table to see where traffic is being routed to. In a large network, you can manually add all the routes to your routers, but this can become very time-consuming. If you use a routing protocol, the routing protocol will automatically build routing tables for you. These routing tables will change as the network changes. For example, if a network is added, the routing table is automatically updated. Routing protocols also support multiple paths. If there is more than one path to the destination, the routing protocol will only use one route. If a network fails, the routing protocol will remove the dead route and use another path if one exists. The first routing protocol is Open Shortest Path First, or OSPF. This is no longer supported in Windows Server 2008. For this protocol, all you need to know is that it was supported in Windows Server 2003, but is no longer included. If you are upgrading from Windows Server 2003 to Windows Server 2008, remember this fact before you upgrade. The next, and in fact only routing protocol supported in Windows Server 2008 is Routing Internet Protocol, or RIP. RIP has been around since 1988, and since that time it has been improved upon. Windows Server 2008 supports version 2 of the RIP protocol. This is the latest version of the RIP protocol for IP version 4. To understand routing protocol and RIP better, consider this network. In this network, there are 3 routers. The first and last routers are connected to an extra network connection. This provides an additional path through the network. If the middle router were to fail, clients on the network could still reach their destinations by being routed through the other routers. The RIP routing protocol will detect the down router and remove any routing entries from its list for that router. When the router is fixed, the RIP protocol will adjust the routing tables. If you decide to use RIP in your network, remember, RIP is based on hops. When network traffic goes through a router, this is called a hop. The route with the lowest hop count gets added to the route table. If all your network connections are the same speed, this works well. But if you have some low-speed network connections, you will find that RIP will route traffic over these rather than over the high-speed network connections if the hop count is lower. This can cause a lot of performance problems. Let's have a look at how to configure RIP. To configure RIP, first open the Routing and Remote Access snap-in from the Start menu. From here, expand down Static Routes under IP version 4. If I right-click on Static Routes and select Show IP Routing Table, I can see the current routing table for this computer. When RIP is enabled, you should see more routes appear in here as they are discovered. To install RIP, right-click General under IP version 4, then select the option New Routing Protocol. From here, select the option RIP version 2 for Internet Protocol. As you can see, RIP is now added to IP version 4. RIP is now installed, but will not listen or send RIP messages until you add some interface to it. If you don't want an interface to be used with RIP, for example, you have a very slow network connection, do not add the interface to RIP, and the interface will not be included in any RIP advertisement. To add an interface to RIP, right-click RIP and select New Interface. From here I can select the interfaces that I want to add. There are 4 interfaces on this computer. I will quickly add the first 3 using the default options. On the last interface, I will go through the options. The first option in RIP is the Operation Mode. The Operation Mode, by default, will periodically send out RIP advertisements. If you wish to switch this off, select Auto Static Update Mode. When in this mode, RIP will not send out any advertisements, and as the administrator, you must manually send them out as required. The Outgoing Packet Protocol option determines which RIP advertisement to use. If you have a router that uses RIP version 1, you can select it here. By default, RIP version 2 will be used as broadcast packets. Broadcast packets are sent to all computers on the network. This is a waste of bandwidth, and also the wrong hands could obtain your routing tables. If you want to try and save some bandwidth, select the option RIP version 2 Multicast, assuming your network supports it. This will use less bandwidth than broadcast. Lastly, you have the option Silent RIP. Silent RIP means the interface will receive RIP messages, change its routing tables accordingly, but will not send out RIP advertisements. At the bottom of the screen, you have the option to activate authentication. By selecting this, you have the option to set a password on your RIP advertisement. This helps prevent eavesdropping of the RIP advertisement. You need to configure the password on the device that is going to receive the advertisements as well. On the Security tab, you have the option to set up security on either the incoming or outgoing routes. By default, all routes will be sent or received. If you want to only send or receive routes in a certain range, you can add them here. Also, you can choose to ignore routes in a certain range as well. On the Neighbors tab, you can determine how RIP will communicate with its neighbors. The default option is to broadcast. The next option is to use neighbors while still allowing broadcast or multicast. This means RIP will attempt to contact the other RIP devices directly and will still use broadcast or multicast depending on your settings. Also, you can add your neighbors in manually, but if you forget to add in a neighbor, a message will still be sent so the other devices can pick them up. The last option uses only neighbors and does not use broadcast or multicast. This means that you need to manually add each neighbor in for the RIP message to be sent to that device. If you forget to add a device, that device will not receive any RIP advertisements from you. Since the RIP device is being contacted directly, this is the best way to stop unwanted eavesdropping on the network and provide enhanced security. Once the interface is added, it will start advertising routes out to this interface to any RIP-enabled device on that network. I will also add the other interface to RIP as well. On the last tab, you can select some options on the timing used for the protocol. The first option sets how often announcements are sent. RIP is known as a chatty protocol, as it sends a lot of messages around the network. Increasing this figure does reduce the amount of data that is sent around the network. However, this also means that changes in the network will take longer to propagate. The time before a route expires will indicate how long a route is dead before the router will advertise it as dead. The default is 3 minutes, which does not seem a long time, but consider once the route is marked as dead on a large network, it can take a while before the router advertisements get through the network and all the routing tables are updated. The next option indicates how long before the route is removed from the routing table. Once a route is considered dead, it is marked as such and no longer in use. It is good to leave this setting so that the route can be advertised throughout the network as dead. Enable split horizon processing and poison reserve are advanced network topics. I would leave these options enabled. In a nutshell, they prevent a dead route being reactivated by a router thinking that it is still alive. In a large network, it is possible to receive a delay advertisement from a router indicating a route is up when another router says it is down. Without these settings, one router might wrongfully add a route as up when it is in fact down. There you have it. RIP is enabled and hopefully will make configuring your networks a lot easier. Once you set up your network or start supporting one, you are going to have times when users complain that their network communications are not getting through. There are two important tools that Windows Server 2008 uses to help troubleshoot routing problems on your network. The first command is traceRT, otherwise known as traceroute. Traceroute shows you the path that packets take across your network. As shown in the example, if I were to perform a trace route to google.com, the traceroute command would show me all the routers or hops the packets go through to get to this destination. As you can see on the left-hand side, traceroute performs 3 pings to each of the routers in the path. This gives you an idea of how fast the communication speed is. If your users are complaining about slow response time, using traceroute will give you an indication of which routers in the path may be congested. If a router is down, traceroute will show you the routers it went through before the communication was lost. On the far right-hand side, traceroute will attempt to resolve each router to an IP address. If a DNS server is slow to respond, this can slow down traceroute. As you can see, after hop 10, there are no DNS records for each IP address. Traceroute stalls for a moment, attempting to perform a reverse lookup on an IP address that it will not be able to resolve. This is a feature you may want to switch off. To do this, use the -D switch. If I perform the traceroute command again with the -D switch, and this time use an IP version 6 DNS name, that is, ip6.google.com, you will see that traceroute worked out the destination as an IP version 6 address, and this time is using IP version 6 to work out the path. Notice on the right-hand side, a reverse lookup is no longer being performed on the IP addresses. This makes traceroute a lot faster. You will notice that hop 2 came up as asterisks for the times and the request timed out for the IP address. If traceroute does not receive a response back, it will display an asterisk. This means that either there was a lot of congestion on the router or possibly a firewall blocked the return packet. So if you see this in your traceroute, it may be normal behavior. The next command is path ping. This traces the route like traceroute. However, the big difference is it provides statistics over a longer period. I will use the path ping with the host google.com. I have added the -4 switch. This forces path ping to use IP version 4. I could also use the -6 switch to force it to use IP version 6. These two switches work in a lot of the Windows command line tools, including traceroute. You will notice that path ping traced the path to the destination like traceroute did, but did not provide an indication of how long each hop took. Once finished, path ping will pause and gather statistical information about the time taken at each hop. In this case, over 425 seconds. I will accelerate time so we can see the results without having to wait. You can see here that PathPing provides an average time to each hop and also statistics on packet loss. If you want to test how reliable your network is, PathPing is a good tool to test with, as it gives you an indication of how many packets were lost over the time period the tests were run. IP version 6 is fully supported in Windows Server 2008 for routing. Before your Windows Server 2008 router will route IP version 6 packets, it needs to be enabled. Earlier in the course, I discussed the concept of a network prefix. If you are using Windows Server 2008 as an IP version 6 router, you should set the IP version 6 prefix. This prefix is automatically assigned to each of your devices on your network. I will go through quickly how to perform these two steps. In reality, it is very unlikely Microsoft will ask you a question on IP version 6 routing in the exam, but going through it does help you understand some of the other concepts better. From the Start menu, launch the Routing and Remote Access tool. Once loaded, right-click your router and select Properties. Tick the tick box IPv6 Router to enable IP version 6 routing. Next, I want to select the tab IPv6. Here you can enter the prefix for your network. In this case, I will use the first private address, FD00. When an IP version 6 computer or device starts up on the network, this prefix will be appended to their host address, giving them a complete IP address that is routable on your network. Remember this for IP version 6. A device or computer uses Discovery to find the network prefix for that network, which is set here. It then uses this network prefix as part of its IP address. For the exam, it is not so important that you remember how to set the prefix, but make sure you understand the prefix is advertised to the client by a router or a DHCP server, and then used as part of its IP address. In the real world, you probably will not use Windows Server 2008 as a router. Most companies will use a hardware router. Windows Server 2008 routing support is good for IP version 6 and includes support for transition protocols like 624. If you are interested in learning more about IP version 6 and transition protocols, then using Windows Server 2008 or Windows Server 2008 Release 2 is a good place to start. Using Windows as a router saves you having to purchase an IP version 6 router if all you want to do is experiment. Remember, for the exam, make sure you understand IP version 4 routing. It is very unlikely Microsoft will question on IP version 6 routing.